Hello good day viewers. In this tutorial we are going to learn how to expand binomial terms when the exponent is either negative or fraction, and we're only going to derive the general formula used for that expansion. Subsequently we are going to be applying the formula in expanding such binomial terms. Alright, let's get started. You should recall previously the formula we normally use for expansion of a plus b raised to the power of n, for which n is a natural number. It is equal to n combination 0 a raised to the power of n minus 0 b raised to the power of 0 plus n combination 1 a raised to the power of n minus 1 b raised to the power of 1 plus n combination 2 a raised to the power of n minus 2, right? Then b raised to the power of 2. This is how you keep on adding these terms till you get to a term that is n combination n, a raised to the power of n minus n, then b raised to the power of n, where these n combinations are said to be the coefficients. So how do we expand the coefficients? You know, to expand them, n factorial, right, divide by n minus 0 factorial, 0 itself factorial. Then you bring the rest of the terms, where we have a to the power of n minus 0, which is the same thing as a to the power of n. Then b to the power of 0 is 1. So we move to the next term, where we have n combination 1, which is n factorial, right, divide by n minus 1 factorial, then 1 factorial. Then you bring the rest of the terms, a raised to the power of n minus 1, then b raised to the power of 1, which is b, then plus, you move to the next term, we have n combination 2, which is n factorial, divide by n minus 2 factorial, then 2 factorial. Then you bring the rest of the terms. We have a raised to the power of n minus 2, then we have b to the power of 2. Let me add one more term, which is going to give us n factorial, divide by n minus 3 factorial, then 3 factorial, a raised to the power of n minus 3, b raised to the power of 3. Then you keep on going up to n factorial, divide by n minus n factorial, n factorial, a raised to the power of n minus n, b raised to the power of n. Alright, this is exactly how to expand a plus b raised to the power of n, for which n is a natural number. But the problem is, what if n is either a negative number or fraction? For example, negative 3. We don't know how to compute negative 3 factorial. Or what about if n is 1 divided by 2? We don't know how to compute 1 divided by 2 factorial. But I know if we keep on simplifying this, we're going to get rid of these n factorials. And let us do that. You can see from the denominator we have 0 factorial, and 0 factorial is 1. And we have n minus 0 inside here, and n minus 0 is n, and n factorial remain n factorial. So n factorial will clearly cancel n factorial. All we have from that first term will be a raised to the power of n. So this is the same thing as a raised to the power of n. Let us move to the second term. You can see we have 1 factorial here, which is the same thing as 1. We don't have problem with that. But what about this n minus 1 factorial? How can we simplify it? We know that a number factorial is the same thing as that number multiplied by the number before it down to 1. For example, if we have 4 factorial, it is equal to 4 times 3 times 2 times 1. So we can write this in terms of this, because n factorial can be written as n multiplied by n minus 1 factorial, right? We can write it as n multiplied by n minus 1 factorial, right? Divide by n minus 1 factorial. Then we have a raised to the power of n minus 1 times b, right? So from here, you can see that this will cancel this. What do we have left? Only n multiplied by a to the power of n minus 1 times b. So we can write it here. Plus n a to the power of n minus 1, then multiplied by b. Here is our third term. We are going to split this n factorial in terms of n minus 2 factorial. So we are going to write it as n multiplied by n minus 1 multiplied by n minus 2 factorial. We're going to stop here because we have n minus 2 factorial to the bottom. N minus 2 factorial. But we have what? 2 factorial. Such that this will cancel this. But remember, we have a raised to the power of n minus 2, b raised to the power of 2. So the whole of these factorials are gone. All we have is n times n minus 1 divided by 2 factorial, then we multiplied by this. So we have plus n multiplied by n minus 1, then divide by 2 factorial. Then we have a raised to the power of n minus 2, b raised to the power of 2. Then we add, let me add one more term. That is term number 4. If you move to the term number 4, we are going to write this in terms of n minus 3 factorial. So if you observe the pattern, we have n times n minus 1 here. We are going to obtain n times n minus 1 times n minus 2. And here we are going to have 3 factorial. Then this will be a raised to the power of n minus 3, b raised to the power of 3. If you want to obtain term number 5, it is going to be n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, right? Divide by 4 factorial, then a raised to the power of n minus 4, b raised to the power of 4. Can you see that? As simple as this. Then next, what if a is equal to 1? We are going to replace all these a's with 1. This will become 1. That is the first term. So this is equal to 1 plus. We are going to replace this a with 1 again. So we have 1 to the power of n minus 1 is still 1 times nb. So we have nb alone at that point. We have nb plus, we move to third term. The whole of this will go. What do we have? We have just n times n minus 1 divided by 2 factorial. We have n times n minus 1 divided by 2 factorial, then b squared, right? Because a is gone. Can you see the pattern? We are going to have n times n minus 1 multiplied by n minus 2, then b raised to the power of 3 divided by 3 factorial. This is how we're going to obtain this. But you should know that we are going to obtain infinitely many terms when we are dealing with a negative exponent or fraction. So let's stop here. But the question is, why do we use this 1 right here? So if we have like a plus b raised to the power of n, before we start expanding, since n is negative or fraction, we can factor out a here. So we have something like a outside, then this becomes 1, right? Then plus b divided by a, all raised to the power of n, such that this becomes a raised to the power of n, then multiplied by 1 plus b divided by a raised to the power of n. So this is exactly what we are going to expand. After the expansion, then we take a raised to the power of n and distribute all through. That is the logic. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.